Have you ever stared into the night sky, gazing at the red dot we call Mars, and wondered if we are alone in the universe? This question has intrigued humanity for centuries, sparking our curiosity and driving us to explore the unknown. Mars, the fourth planet from our Sun and our celestial next-door neighbor, has been the subject of fascination, speculation, and exploration. Its reddish appearance, visible even to the naked eye, has earned it the affectionate moniker, the Red Planet. But it's the possibility of life on Mars that truly captivates us. Could this cold, desert-like planet, with its thin atmosphere and extreme temperatures, actually host life? Could the mysteries of the universe, the secrets of life beyond Earth, be hidden on this distant, seemingly barren world? These questions drive our relentless pursuit of knowledge and exploration. Could the Red Planet hold the answers we seek? Let's dive into the journey of Mars exploration. The quest to answer this question has led to numerous missions to Mars. Our journey of Martian exploration commenced in the 1960s with the Mariner missions. These pioneering expeditions aimed to gather basic data on Mars' atmosphere and surface, laying the groundwork for future endeavors. Next came the Viking missions in the mid-70s, Viking 1 and 2, the first spacecraft to successfully land on Mars. These missions not only sent back fascinating images of the Martian surface, but also carried out experiments searching for signs of life, although the results were inconclusive. Fast forward to the late 90s, Mars Pathfinder made its mark. Deploying the first ever successful Mars rover, Sojourner, it demonstrated the feasibility of low-cost landings and roving exploration on the Martian surface. The new millennium saw the launch of the twin rovers, Spirit and Opportunity. These robotic geologists outlived their planned missions, with Opportunity exploring for nearly 15 years. Their discoveries of evidence related to past water on Mars were groundbreaking. In the mid-2000s, the Mars Reconnaissance Orbiter joined the fray. With its high-resolution camera, it has provided unprecedented details of the Martian surface, assisting in the selection of landing sites for future missions. The Curiosity rover, part of the Mars Science Laboratory mission, landed on Mars in 2012. Carrying the most advanced payload of scientific gear ever used on Mars's surface, Curiosity continues to explore and send back valuable data. And most recently, we have the Perseverance rover that landed in 2021, carrying the Ingenuity helicopter, the first aircraft to fly in Mars' thin atmosphere. Perseverance's main goal is to seek signs of ancient life and collect samples of rock and regolith for possible return to Earth. Each mission has brought us a step closer to answering the enigma of life on Mars. As we continue our exploration, we build upon the legacy of these missions, each one contributing to the complex puzzle of the Martian environment and its potential for life. These missions have made discoveries that have reshaped our understanding of Mars. The robotic explorers tirelessly traversing the dusty Martian terrain have revealed compelling evidence of water, a crucial ingredient for life as we know it. They've uncovered ancient riverbeds and polar ice caps, and even signs of past liquid water. These discoveries have ignited a spark of hope, suggesting that Mars could potentially harbor life. But water isn't the only intriguing discovery. The Martian atmosphere, thin and predominantly composed of carbon dioxide, has also presented us with surprises. It offers some protection from harmful solar radiation, a crucial element for any life form. And that's not all. Recent studies have detected traces of methane in the Martian atmosphere. Here on Earth, methane is often produced by biological processes, leading to speculation that there could be microbial life hidden beneath the Martian surface. The Mars missions have also revealed the possibility of liquid brines. These are essentially saltwater solutions, which could potentially exist in the extremely cold and dry conditions on Mars. On Earth, we know that some hardy microorganisms, known as halophiles, can survive in high salt environments. Could similar life forms exist on Mars? It's a tantalizing question, but the Martian environment is harsh, and many challenges remain. The thin atmosphere, the extreme cold, the lack of liquid water, and the intense radiation from the sun all make it a formidable place for life as we know it. Nonetheless, the discoveries made by the Mars missions have painted a picture of a planet that, while starkly different from Earth, may have once been habitable. These discoveries have painted a picture of Mars that suggests it may have once been habitable. They've opened up a whole new world of possibilities and have sparked a renewed interest in our red planetary neighbor. As we continue to explore Mars, Each new mission brings us one step closer to answering one of the most intriguing questions of our time. Is there life on Mars? But could life survive in the harsh Martian environment today? That's the question that has been at the forefront of Mars exploration for years. The Martian environment presents a set of formidable challenges for life as we know it. Let's start with the temperatures. Mars is a frigid world. Its average temperature hovers around a chilling -80 degrees Fahrenheit, dropping even lower during winter nights. Such extreme cold could prove lethal to most known organisms, presenting a significant barrier to life. Next, we have the Martian atmosphere. It's incredibly thin, about 100 times less dense than Earth's atmosphere. This thin atmosphere offers little insulation, allowing the heat from the sun to escape into space and leaving Mars in a perpetual state of cold. Also, the Martian atmosphere is predominantly made up of carbon dioxide with only traces of oxygen. Without a substantial amount of oxygen, it would be challenging for oxygen-breathing organisms to survive. Another hurdle is the high levels of radiation. Mars lacks a global magnetic field and has a thin atmosphere, two elements that on Earth protect us from harmful solar and cosmic radiation. On Mars, this radiation penetrates the surface, posing a potential threat to any form of life. And let's not forget about the Martian soil, or regolith. It's laced with perchlorates, chemicals that can be toxic to many forms of life. The presence of perchlorates could make it difficult for life to gain a foothold in the Martian soil. So, to sum it up, Mars is cold, its atmosphere is thin and lacks oxygen, it's bombarded with high levels of radiation, and its soil is filled with potentially toxic chemicals. These conditions make Mars a hostile place for life as we know it. Yet, life on Earth has shown an astonishing ability to adapt to extreme conditions. This resilience is epitomized by a group of organisms known as extremophiles. These fascinating creatures thrive in environments that would be inhospitable, if not downright lethal, to most other forms of life. From the scorching heat of volcanic vents to the icy depths of Antarctica, extremophiles have proven that life can persist in the face of adversity. Extremophiles, as their name suggests, are extreme lovers. They have evolved over millions of years to withstand not just the extreme temperatures, but also high radiation levels, intense pressures, and near total darkness that characterize their unique habitats. This remarkable adaptability makes them a fascinating subject in our quest to find life on Mars. Scientists believe that if life can exist in the harshest environments on Earth, then it's not entirely out of the question that life, however rudimentary, could exist on Mars. The conditions on the Red Planet, though extreme by our standards, are not unlike those faced by Earth's extremophiles. In fact, some of the most inhospitable places on Earth, such as the dry valleys of Antarctica or the acidic waters of Rio Tinto in Spain, are considered Mars analogues because they so closely resemble the conditions on Mars. Though Mars is colder and drier than any place on Earth, the presence of water in the planet's past and the discovery of methane in its atmosphere suggest that the conditions necessary for life might once have been present. And if life did arise on Mars, extremophiles might be the last survivors, clinging to existence in the planet's subterranean depths. While we have yet to find definitive proof of life on Mars, the study of extremophiles here on Earth gives us hope. They are testament to life's tenacity and adaptability, reminding us that life often finds a way, even in the most unlikely of places. The existence of such resilient life forms on Earth encourages us to explore the possibilities of life on Mars. So, is life on Mars possible? Let's recap what we've learned. Mars, the enigmatic red planet, has been the subject of countless space missions, each adding a piece to the puzzle and bringing us closer to the answer. These missions have unveiled signs of ancient water bodies, conditions that could have been suitable for life as we know it. Today, the Martian environment is harsh and inhospitable. However, the existence of extremophiles on Earth, organisms that can survive extreme conditions, suggests that life in some form could endure the tough Martian environment too. The presence of methane gas in the Martian atmosphere further fuels speculation about potential microbial life beneath the planet's surface. While the conditions on Mars today are hostile, past conditions may have been more suitable for life. The quest for life on Mars continues, and each new discovery brings us one step closer to answering this fascinating question.